Hey, and welcome back to Any Bit Fever Dreams. This is going to be a tutorial guide on all the ways you can use to run a program on the F256 platform. Most of you who own a machine will figure out the easy ones on your own. But there might be some scenarios you're not aware of, and you might be learning a thing or two of what's happening behind the curtains. So, allow me to roughly start with the easiest method and go all the way to convoluted ones that involve the flash cartridge, filling up the flash memory differently and whatnot. Basically, I'm making the video I wish I had seen at the beginning of my time with the platform. Let's start with the easiest one of all. Whether you have experience with the Commodore 64 or not, this is even easier than that. You don't even need an SD card for storage to get going, since you can run a basic program listing from memory. This is the environment you land in when you get your machine off the shelf, if you will. Let's type the typical real quick program, 10 print high with a semicolon at the end, 20 go to 10 and run. But let's say you do have an SD card and you want to save this. Just call save first.bas. This blue LED lights up while the SD card access is going on. Now let's power cycle the machine to make sure we start fresh. Loading back the program would simply be load first.bas. Then to execute it, just do run. Nothing earth-shattering here, so let's move on. This is the level where a lot of people will start and where they'll stay at most of the time. An executable program will have the file extension .pgz, .pg capital Z, or pgx. To launch it, simply type / dash or hyphen, space, then just the name of the program. The dot and the 3-letter extension is not necessary, but it doesn't matter if you include them. For example, if your program is balls.pgz, then you can get away with just / dash space balls, but adding .pgz will also work. Be aware that lots of programs don't include a graceful exit, so you'll be hitting that reset button quite often, and maybe you'll also reach for a proper power cycle. If a program moves things around in memory like alternative fonts or graphical settings like double-sized fonts, border size and color, or there's a trailing musical note, just go for a power cycle. Now, eventually, you have to understand what this / and dash symbol are about. I'll explain it in the next method. When you're in SuperBasic, and only in SuperBasic, the / symbol tells the interpreter to prepare for loading a flash-based program and to start executing immediately. In this method, you have to start understanding the architecture of your machine just a little bit to see what's going on. The flash memory has a capacity of 512K and size matches the onboard regular RAM of the machine, also 512K. Now, when you buy and receive a F256 machine, you'll have a small collection of programs preloaded in your flash. In time, you'll be able to tweak this to your liking, but for now, let's find out what it comes with. One of these programs is more or less a nifty text editor. This is not a PGZ or PGX. It's a special format meant for flash memory, so it has a different compilation method, but let's just use it for now. I hope you noticed I did not include a dash and I did not include a space. / tells SuperBasic to launch something followed by the name. There's no 3-letter extension in this case for programs residing in flash. This particular program does include a graceful exit, just hit Alt-X and you're back to basic. Let's try something else. / DOS. DOS is a bare-bones shell program. Usually DOS used to stand for Disk Operating System, but it's kind of a bad name nowadays since you're not really depending on diskettes to run anything now. But anyway, this DOS gives you a nifty environment that lets you do some file manipulation that isn't available in SuperBasic. I'll come back to DOS a bit later. Let's go back to BASIC. So now you're ready to learn what we were doing with /dash. If things were set up thoughtlessly, you could have been forced to do /pexec space myprogram.pgz. However, an alias was created and pexec can be replaced with a simple dash symbol, /dash space myprogram. Let's recap. This notation only works in SuperBasic because slash means launch something from flash. The dash symbol means that we're calling this pexec program, and its role is to do the proper loading of an executable program at the right places in memory. And myprogram is your one extra argument that tells pexec what to load from the SD card, which is the default drive. That's a fair amount of knowledge to take in, but the good news is that it's easy to remember and use all the time. DOS is an early days shell program in the F256 world that just kind of sits there, and not everyone is aware of it. But it's simple, practical, and very reliable. It does have a really useful command that you can't find in SuperBasic. Remember what I told you about having a suite of programs preloaded in Flash? You might naturally ask yourself, what is in there, and how do I learn what their names are? Well, in DOS, you can type help to get a list of everything you can do in this, and this command, lsf, will give you that list of Flash executable programs. Let's try it. As you can see, there's the mless, the more or less program we saw earlier. There's the dash program, which is the alias for pexec. We even see DOS itself in that list. A power move at this point would be to add programs to that list, and you totally can. There's room to spare. When you get a brand new F256, you don't get bloatware filling up all that room in Flash. But that's a topic for a later method. When you do, however, LSF is a great way to see if you've done it properly, since it should show up in that list if it has the proper header for being a runnable Flash program. In this environment, you just type the name of the program itself. There's no slash nor dash needed here. Okay, yes, the difficulty drops down a bit here, but you needed to learn about the previous methods to fully appreciate this one. F-Manager or Phoenix File Manager is a tool made by Mica and exists in two forms, as a Flash program or as a PGZ file. Personally, I think spending a few blocks of Flash memory to load this program makes a ton of sense because loading from Flash is the best in terms of speed. You may or may not already have FM as a Flash program depending on exactly when you got your F256 machine. In order to get it in there, wait until the end of the video, it's covered later. The worst case scenario would be to get the PGZ version of it on your SD card and execute it from SuperBasic. File Manager is a text-based browser of pretty much everything in storage and memory. Some of you might get Norton Utilities vibes out of this if you have experience with old MS-DOS IBM compatible PCs here. You can easily browse the content of your SD card and even have two locations side by side. Either location can be any of the drives in the machine. Drive 0 is your external big SD card, but as you can see, there are other locations you can put up. Here's the flash if I press 9. But let's go back to the topic. To simply run a program, just navigate to it and press enter. This is the equivalent of using dash in either SuperBasic or in DOS. But wait, there's more. Some file extensions are special and have an associated program for them. If I try to launch a .txt text file, it'll automatically send it over to more or less, fully opened up right away. Let's try launching a .bas program now. And as you can see, there are instructions in how to proceed. So I just press a key, then type X go, and boom, my basic program is loaded up. That's just a bit faster than doing it in method 1. This means FM could be a great starting point program that could immediately pop in when you boot your machine instead of SuperBasic itself. Whether you choose to do this or not is entirely up to you, but you have to rearrange things in the flash memory. More on this method later. Last but not least, some other file extensions have associations. If you try to launch a .mid in FM, which is a MIDI music file, it'll send it to an associated program called midiplayer.pgz inside the folder _apps. It launches right away. Bear in mind that MIDI playback will only sound off in the second wave of F256 machines, since they are the ones to have the onboard SAM2695 MIDI chip. Program will still run on the first wave K or Junior, and you'll see some graphics and activity, but no sound. This standard MIDI file player was coded by yours truly. Here's the full list of extension associations and their respective program. Let's try to do something wild and open up an MP3 file. Again, the K2 or Junior 2 are needed here, since they rely on this VS1053B sound chip that the first generation doesn't have. Again, coded by yours truly. I also happen to add some flourish on the small LCD screen on the K2 case and show off a little spectrum analyzer, but you also get it on the main screen regardless of if you have a K2 or a Junior 2. Press F1 for a different color scheme here. Let's try out a wave sound file. It's the Windows 95 startup chime. This is cursed. Cursed, I tells ya! For those of you who are very nostalgic for disk drive days and don't mind the pain of diskettes, there's an IEC port just like in the Commodore 64 days. This means my vintage unmodified 1541 drive can be used as a storage for my F256. Plug it in your IEC port and it's now accessible to SuperBasic, DOS and FM as Drive 1. So let's test it out in SuperBasic. I type in the command Drive 1. And then you can use the directory command, save, and load just like usual. Let me save a basic program real quick. In FM, you can type 1 in one of the views to dedicate it to the drive. Let me copy a program to it real quick. And finally, in DOS, change to that drive with one colon first, then you can use the drive. Let's try to load a program that I saved a minute ago using the flash dash program, followed by the program name found in the diskette. I'm going to show how it's done on a Windows machine, since this is what I own, but this could be done with Mac OS or Linux. This is going to require Python installed on your modern computer. Installing Python is outside of the scope of this video, so if you have to do it, pause the video and come back when it's done. If you have a Junior or K from the first wave, then you need a USB cable with USB-A on one end and mini USB on the other. They're still available, but much less used today. If you have a Junior 2 or K2, then it's a USB-C cable. The script we're gonna use is called FoenixMgr or FoenixMgr, and it's present here. There's no installation package or anything, so you have to clone that repo using a tool like Git. If you're not super familiar with Git, you can find clients that deal with the commands in the background of a front-end program like GitHub for Windows. This could feel it's a step up in difficulty if you've never connected properly to a GitHub repo, but in a nutshell, what you need to do is to create this local copy of FoenixMgr on your machine. Don't copy the files one by one. Do it in one single go. It's an operation called cloning a repo. Find a tutorial on this if you need to, since it'll escape the scope of this video again. Come back when it's done. Now that you've dealt with it, you're gonna head over a command window. One piece of information that must be established is which communication port number is used when your USB debug cable is plugged in your Phoenix machine. To find that out, the F256 must be powered on and the debug cable must link your modern computer and your Phoenix. Then one or several COM ports are established. Just type MODE for mode to find out about them. For the following, I can only speak strongly from experience with my K and K2, but I imagine it's similar for the Junior and Junior 2. On my K, I would only see one COM port opened, while on the K2, there's 3 of them. Whatever your specific COM port number, you need to bring that in FoenixMgr.ini and paste it in this line. Then you use one of these batch files in the command folder. Let's start with runpgz.bat or runpgx.bat. These will send over the program to the right areas of memory on the Phoenix and force it to start immediately. There's no local copy into the SD card or anything. This is basically what programmers do when they want to test out their code without the fuss of deleting old versions and copying new versions. Sometimes it'll get hung up on this microkernel text screen. Just send it again to resolve the snag. If you do want to copy the program for any reason, let's say it's your final version or you're done for a while, then you use the pcopy script and let the progress information finish and stall on your Phoenix machine before you reboot. By default, it's sent on the root folder of your external SD card. This one requires a bit of knowledge about how things are set up on a Phoenix once more. Sending a binary .bin file is going to fill in a specific area of RAM. There are several options when you're doing this. First of all, let's see how the script is used. The first argument is a binary file, and the second is the address in hex. For example, to send it to 10,000 hex, just write this. The X number has no 0x in front of it, or it doesn't have an H at the back of it, or a $sign. Just straight text, but it's implied that it's an hexadecimal character. Before we get further, let's talk about why we would need to do this in this way. If we go back in time to the early days of the F256 platform, people were mostly making SuperBasic programs, or they would do their first serious programming in assembly using the 64 task compiler. Initially, before people got experience with it, they were compiling their thing into a binary file, meaning code and data mixed together. But critically, they were not including PGZ or PGX header information, so it couldn't be run with the methods I covered in the beginning at all. The majority of people shy away from doing things this way nowadays. It can still happen because it's called taking over or owning the whole machine, and the intention is to completely steamroll the memory before SuperBasic and the kernel have even a chance of being loaded as the machine is booted. So the full chain of commands you need to do is 1. You have to force the F256 into a boot from RAM mode. Use bfr.bat to force this. 2. Send the binary to a specific address in RAM. Exactly where is up to the developer who made the program. That person has to provide the address, or you'll have to blindly guess where. Sometimes it's going to be at address 0, sometimes it's higher. Step 3, finally, since you're in boot from RAM mode, the first program it'll find with an executable signature will be run first. If you sent it to address 0, there's no doubt that it'll find it right away. If it's higher, then the first program it finds will be run. Note that these bin files don't have the same header as PGZ or PGX programs. It's less complicated as it carries less information. Now, before we continue on the next method, we have to understand exactly what is given up by loading programs this way. Putting into a program means that SuperBasic isn't involved at all. The other major thing that is being given up is the kernel. If you're not familiar with the C64 world, it's possible you have no idea what a kernel is in this context. Basically, what it boils down is that a kernel does low-level operations like fetch keyboard key hits and releases, and prepares events for your application to pick up. It has routines in place to open, read, and write files, communicate with the serial ports, that sort of stuff. There's nothing preventing you from ignoring the kernel, removing it from your machine, but it sucks having to reinvent the wheel all the time. The kernel is brilliantly put up together, so all those programmers who made bin files in the early days of the platform made the decision to do small demos and tests that could live without the kernel. Some of them do have keyboard hit detections, like this Living Worlds demo by Hayden Kale. It means she coded her own keyboard hit detection routines. If you're ready to do programs for the F256, I strongly recommend staying away from making bin files at first, unless you really know what you're doing. Just find a compiler that can produce a PGZ or PGX and learn to love and coexist with that kernel as much as possible. Before I continue here, I should let you know that another great GitHub repo has the so-called standard collection of Flash programs out there. Also, it's really helpful that it comes into release packages in the form of a big old zip file, so you don't need to clone this repo, just grab the file and extract it wherever you like. This is a good, well-thought-out grouping of Flash programs that should serve most people for a long time. It also tries to grab the latest kernel revision, the latest FoenixMgr scripts, the latest SuperBasic program, and everything else. It's supposed to be the one launching pad for updating your F256, and it removes the need for you to hunt for all of these things individually. It's called the firmware release. But if you watched until this point, it's time to mess about in this configuration, yeah? First thing you do is open the CSV file called bulk CSV, or comma separated values. It can be opened in a text editor or in Excel. You'll instantly recognize the list of programs we saw earlier in method 4 when we were checking out stuff with LSF and DOS. The first line for lockout.bin at 3F is there for some bug fix years ago. I'm not super sure it's still necessary at this point, but we keep it there for good luck. That flash block of 3F gets rewritten later anyway. Just don't mess with it, because when you do, this happens. Next, block 1 carries xdev.bin. This has to be kept there for your Python scripts to work, the ones called runpgz, runpgx, and pcopy of method 6. Don't overwrite this unless you really don't need that great functionality from FoenixMgr. After that, the field is wide open for any tweak you'd like. If you'd want to launch into File Manager instead of BASIC, every time you boot the machine, you can do it. Just swap those blocks around and start your FM group at block 02 and up. Simply put BASIC later down the list at a higher starting block number. If you're a power user and you made a bunch of new tools that can launch from Flash, you can add them there, but they require special preparation. Whenever you want to make a big change, whether it's a deliberate decision because you want to scramble things around, or the firmware package as a new big shiny release, it's best to start with a -- erase command first, to make sure you don't have remnant blocks from old programs lost in Flash, and you start fresh from writing to Flash with the bulk.csv list. Last detail, you should steer clear of the last 5 blocks of Flash from 3B to 3F, because the kernel is occupying that space. You won't see it as a launchable program under DOS's LSF because it's not a program. But most firmware revisions dedicate these last blocks for it, so be careful and leave them alone. The Flash expansion cartridge is yet another way to deal with programs. You can buy one from the store here, and in my opinion, they are a really cool way of making sure the loading times are obliterated to almost nothing. No one at the moment is selling their piece of software on carts like it was the classical way to distribute software back in the 80s. They're a little too expensive to do this, but one thing that's available to you now with the Phoenix platform that wasn't the norm back in the 80s is that it's super easy to write and rewrite the flash memory. To do this, it's necessary to use a tool on the F256 platform itself. It can't be easily done outside of it. Martin, aka MGR42, has made truly excellent tools to aid you in this, and it's been part of the firmware, and you probably already have it if you're up to date. You may have spotted it earlier, but it's called Fcart. So launch that, and you're greeted with a text interface. At this point, you can pop out your SD card and bring what you'll want to write to it while the Phoenix waits. However, you can't just push a PGZ or PGX to it. The program has to be prepared with a cup header, and Martin has prepared a useful program to do so, right here in yet another repo called PGZ2Flash. The repo has a Windows binary.exe file, but if you're on another platform, you'll need to have a Go compiler, 64 tasks, and GNU to build it. This is not difficulty 8 for nothing. And if you have none of these things and you don't know how to proceed, you could always bug a friend with a Windows machine to process your program for you. Let's test it with one of my apps that has a fairly long load time because it targets the K2 small LCD screen. It refreshes the little bitmap in there with my own graphic. It also loads another bitmap in RAM for the main screen. So the hope is that it's going to load faster in the cart. So I run the script with this command line and choose to construct this .bin file. The stuff you see in quotes are part of the cup header, and it's the description and program name you'll eventually see in DOS if you ever do the LSF command. I bring back my SD card, and I type my bin file name here and choose block 0 to put it at the start of memory. Finally, I just reboot the computer and see how fast this whole thing is now. It barely takes a second before it goes to the LCD bitmap loading time. It's all good, right? There's still a problem. We just painted ourselves in a bit of a corner here, and I'll explain what it is and how to get out of it shortly. But first, you get a bonus method here. This is a method that can be prepared at the same time as method 10. The same PGZ2Flash program can also output what you need to convert your program to the onboard flash. All you need to do is to tweak the command line and add an extra parameter, -onboard, followed by the start block number. You should revisit method 9 if you're unsure of what number you should choose, or just look at the flash content under File Manager. Be aware that your program will be divided into 8 kilobyte files. You can slide the resulting files into the bulk.csv file and be on your merry way while you do the steps of method 9 again. Your flash content will be improved by your new program. And now let's get back to the issue for the flash cartridge I was talking about a minute ago. So here's an interesting problem that happens when you have something in your cart that will automatically launch as soon as your F256 boots. And don't get me wrong, that's great. That's what cartridge games did back in the 80s. That program may fill the whole space or just take up part of it. But you have no say in the matter. Whatever program that resides the lowest inside its flash memory will boot. So the question is, how do you change that? Or how do you erase it? In order to do this, you'd have to exit out of that program and return to SuperBasic, or FM, or DOS. But remember, not every program includes a graceful exit. You might think, okay, let's remove the cart, boot the machine normally, then while we're in SuperBasic, let's insert the cart. I'm gonna stop you there. You can't do this. It's not electrically safe to do this because you might bring your power unevenly as you insert the cart at an angle. It's best if you don't. So that's the chicken and egg scenario. The solution is not that tricky, so bear with me. First, there's a way to get out of this forced boot situation. You need to flip the leftmost dip switch and put it in the upward position. For the K units, those switches are located on the underside of the case. In the wiki pages about the dip switches, this is referred to as putting your machine into boot from RAM and dev mode. This will prevent the boot process from searching for a program in the cartridge, so you'll be able to go onto SuperBasic once more, even if the cart is inserted. Congratulations, you'll now be able to edit your cart again. By the way, if you want to start over with your cart, just do Fcart space erase all data. This will let you start over. Second, what we need to do is to dedicate the very first block inside the cartridge so that it carries a program loader of some sort. He constructed a cup bin file called loader.bin that you put in at the very first block 0 of that cart. It gives the best of all worlds. It shows you what's inside the cart and lets you load it, meaning you can have a handful of useful programs instead of just one. And crucially, it gives you that important graceful exit to SuperBasic if you need it. If you need to update the cart, you can. The cart will no longer get in your way. It will no longer stop you from being able to launch Fcart to modify the cart itself. If you want an even more meta solution, the cart can itself carry the cart writing software. That's pretty neat. Martin suggests to put the cartridge.bin from his repo in the last block number 31, so you can have the widest possible free space in the middle. This is not necessary, but again, it saves you a few steps. Let's say you want to modify the cart's content. Those would be two possible paths depending on whether you choose to have this cartridge.bin program or not. Alright, buckle up my friends. So far, every method from 1 to 11 has been related to running stuff in 6502 and could possibly work in 65816 mode. They rely on SuperBasic to be interpreted, or they may or may not rely on some microkernel routines, or they just rely on pure CPU instructions. There's yet another framework that's been built up by Peter, aka PJW, called Toolbox. In a nutshell, Toolbox aims to let you play in the 65816 extended core mode, where all of the RAM is accessible at once. This is in contrast with the classic core where RAM access is limited to chunks of 64 kilobytes with the Memory Management Unit, the MMU. To simplify things, these two cores are helped by these two so-called support layers. Toolbox offers many low-level functions in assembly and in C, and their goal is to make sure you don't have to reinvent the wheel for many operations, like file loading, device buffer streaming, that sort of thing. A close analogy would be that it's similar to the vintage 68K Macintosh ROM-based Toolbox. Only a few people have tried the Toolbox and the extended memory map so far, so this is why I've put it at difficulty number 10, since it's currently outside of many people's comfort zone. However, things might be steered into that direction soon with the upcoming new FPGA cores that promise to seriously boost the 65-816 world by doubling the CPU speed. The scope of all this far exceeds this little video. So let's get back down to earth. If you want to test programs compiled specifically for this environment, you have to apply many lessons learned in the earlier steps. First, you have to completely change your flash memory by going to this repo and using this package from PJW, simply called Toolbox. If you're using a K2, then your point of entry would be the second core enabled by the dip switch at the back. By default, both switches are down towards the bottom of the unit, meaning a value of 00. If you flip switch 1 up, you'll get the 10 configuration and will enable the F256K2 extended map load in which the Toolbox thrives. The switch you have to flip up is the one towards the power connector, rather than the one towards the video connector, if that makes it clearer. When you finally reboot your machine, you'll be greeted by the Toolbox's intro screen as it tries to find a Toolbox-friendly PGZ program. We're not finished yet. Now, this is not a programming tutorial, but in order to prepare your Toolbox using programs, you have to skedaddle over this other GitHub repo, Phoenix Toolbox Client, also from PJW of course, and clone it. There are a few example programs that you can compile with the Calypsy compiler, and I've taken the liberty of producing the relevant PGZ files for you and added a link to them for easy download if you want to go all the way with this method. Now, remember that intro screen we saw earlier? It's looking for a specific program name called fnxboot.pgz. So to try out one of the example program files, you have to copy them over to the SD card, and you have to decide which one of them will act as the booter program. Let's say it's the Hello World program, and let's see what it does during booting. Okay, it's doing a Hello World thing, big surprise. So let's try this other one. I change back fnxboot.pgz to hello.pgz, and I rename tester to fnxboot. As you'll see, this is currently probably the best choice out of the three because it gives you a micro command line interface. Crucially, one of the commands lets you run another program. So in essence, this is a program launcher in the Toolbox environment, just like you expect SuperBasic, DOS, or FM to do likewise. So there you have it. This was quite the ride. My sincere hope is that you learned something out of it. If you're a beginner, you definitely need to use and master methods 1 to 5. When you're ready to program your own applications, then it's time to move to method 7 or higher. Let me know in the comments if some details of this presentation could use clarification, and I'll pin the best answers in the comments. As always, take care, and I'll see you next time in the Phoenix community.